So I want to share this experiment I did, which I think is really important. I'm trying to look for a change in the weight of the jug containing a little bit of water and water vapor, completely eliminating the idea of buoyancy being the cause. I did experiments like this with a digital scale under vacuum, but I wanted to do a mechanical balance version. So it contains a little bit of water inside the jug. As you can see, it's bulging out under the vacuum. Cap was put on very tightly with some Teflon tape. It's under vacuum of about minus 30 inches of mercury. Each line there represents 0.1 grams. So here, what I'm doing, that flashing light, is I'm just shining a heat lamp on the jug through the plexiglass top of the vacuum chamber. And the video here is in time lapse, so it's happening very quickly. The process is pretty slow to watch, but like watching paint dry, but much more exciting. So I'm just shining the light there on, kind of on and off. And if you look carefully, you'll see the needle move. And again, each line there represents about 0.1 grams. The changes here are about the same magnitude as with the digital balance experiments. So I mean, this should not be happening if buoyancy is an explanation. The really important thing to note here is that the weight returns when I remove the heat lamp. So in other words, as the water vapor inside the jug cools down by radiation, its weight goes back to where it was. So here I'm just I'm now letting the air back into the chamber, and you're going to see the jug collapse under atmospheric pressure. So it's pumped down to minus 30 inches of mercury in here. And that's just a little glass food jar with the lid on very tightly. And it's a little bit of charcoal, ground charcoal briquettes in there, and it's a little bit of water. So this is the laser dot here coming from outside and then reflecting off a little mirror down there onto this piece of paper. Just as it makes the balance more sensitive to very, very small movements. So what I'm going to do is shine this light on the jar inside there and see if it changes the weight here, makes it lighter. And then if it comes back a little while later. So this should rule out any rule out buoyancy completely as a cause. Now, if you're patient enough to watch this clip, you'll see the red dot slowly move to the left, indicating a small loss in weight. Now, the reason I think with the glass jars, what I've found is the reason why it seems like it doesn't go back to baseline, or it doesn't regain its weight, is because glass jars act like little greenhouses, and you can shine the visible light into them and warm up whatever's inside, but when whatever's inside gets warm and it re-radiates infrared energy, that can't escape through the glass. So the process of cooling or shedding its internal energy is far slower than through the plastic jug, which is made of high density polyethylene, any milk jug, for example. This material has this property of being able to transmit far infrared really well, whereas glass acts like a mirror and so do some other plastics and materials, a lot of other materials as well. So it seems that what might be the cause or the mechanism for why water vapor rises into the sky and forms clouds may have nothing at all to do with buoyancy. So I wanted to try this, heating this up and then letting it cool under vacuum. This is just copper. So previously I tried something similar with brass on a digital balance under vacuum, and there was some weight change, but here I just want to eliminate, just for good, just to eliminate any possibility of it having to do with the digital balance errors. So what I'll do is I'll heat this up over a propane burner. So what I'm going to be looking for primarily is just a change over time as this cools down. So right now it's the needle is right kind of on the red line there in the middle, and each marking is 0.1 grams, and this is about 200 grams. So I've seen clear weight changes with water vapor and what I want to just confirm is the weight changes as a function of temperature with solid metal. I've also been seeing that too, but just want to see it here on a mechanical balance under vacuum. Get it up here. Okay, I think that's probably hot enough. 250. Well, 280. That's about 300 degrees. Yeah, there's a little bit of oxidation on there, so I acknowledge that, but that's not going to be important. Because I'm going to start from where it is under vacuum there, try to read that. Pretty much there. Most of the air has been pumped out. The only way that can cool down is by conduction into the balance arm or radiation. So it looks like that's where the needle is right now. So it's like one mark to the right, which means it is a little bit heavier, 0.1 grams heavier. But I'll come back here after a while, see where it's at. Just placing directly over top after over a day, 25 hours. looks like the needle has moved a bit to the right.